The Wollemi Pine. Believed extinct for roughly 2 million years and known to science only through fossil records dating back over 90 million years, the Wollemi Pine was quietly rewriting botanical history the entire time, hidden inside a single remote sandstone canyon in Australia's Blue Mountains. In 1994, a park ranger on an off-duty canyoning trip stumbled across a small grove of tall, unfamiliar trees with strange, bubbling, chocolate-colored bark, a discovery botanists later compared to finding a living dinosaur. Today, the wild population consists of fewer than 100 mature trees confined to just a handful of narrow, nearly inaccessible ravines, and the exact location remains a closely guarded secret to protect it from disease, poaching, and the kind of foot traffic that could permanently damage such a fragile remnant population. Genetic testing has revealed something remarkable about that isolation, since every wild tree shows almost no genetic variation between individuals, suggesting the entire species survived the last major ice age as a single relict population that never fully recovered its genetic diversity afterward. Conservationists made the unusual decision to propagate the species commercially soon after its rediscovery, selling cuttings to gardens and collectors worldwide specifically to reduce the incentive for anyone to illegally collect material from the last wild grove itself. Individual trees can produce dozens of separate trunks from a single root base, and some of those trunk clusters are now estimated to be centuries old, despite the species having only been known to modern science for a few decades. The devastating Black Summer bushfires of 2019 came dangerously close to wiping out the entire wild population, and firefighters ultimately carried out a covert operation to protect the secret grove, dropping fire retardant and setting up irrigation systems specifically to save the last truly wild Wollemi pines left standing anywhere on the planet. The Loneliest Tree. On a steep, wind-battered cliff on one of New Zealand's remote Three Kings Islands stands a single tree, and for decades that one specimen was the entire known wild population of its species anywhere on Earth. Discovered in 1945 by a botanist surveying the island, Pinantia baileysiana grew alone on a scree slope too steep and rocky for the introduced goats devastating the rest of the island's vegetation to ever reach it. Every entry on this list traces a genuinely different path toward the same devastating outcome, and Garden's lab keeps documenting species this close to disappearing entirely, with a new deep dive posted every few days into the world's rarest surviving plants. Because the species typically grows separate male and female trees, and only a single female specimen had ever been found, natural reproduction seemed biologically impossible until researchers discovered the lone tree could occasionally self-pollinate using trace male structures within its own flowers. That unlikely biological loophole allowed botanists to successfully grow seed-bearing offspring for the first time in 1985, and the species has since been replanted across the island and in gardens throughout New Zealand, though the original wild tree remains the only individual that species has ever produced entirely on its own, the Franklin tree. Discovered blooming along the banks of Georgia's Altamaha River in 1765 by the botanist John Bartram and his son William, the Franklin tree was already growing in a strangely narrow patch of land barely a few acres wide, and no other wild population was ever found anywhere else on the continent. The Bartrams collected seeds and successfully grew the species in their Philadelphia garden, an act of foresight that turned out to save the entire tree from vanishing completely, since the last confirmed wild sighting came in 1803 and no naturalist has ever located a living specimen growing wild since. To this day, nobody knows exactly why the species disappeared from its native riverbank so completely and so quickly, with theories ranging from wildfire and flooding to an introduced fungal pathogen carried in on nearby cotton fields. Every Franklin tree alive anywhere in the world today, whether in a botanical garden, a private yard, or a specialty nursery, descends directly from those seeds the Bartrams carried back to Philadelphia over 2 centuries ago. Its fragrant, camellia-like white flowers bloom unusually, late in the season, often into autumn, a striking display that continues captivating gardeners even though the tree's original wild home has been permanently and mysteriously lost. The St Helena Gumwood, once forming dense woodland across roughly a third of the remote South Atlantic island of St Helena, The gumwood tree was steadily cut down for firewood and building material after European settlement, reducing that entire ancient forest to a single fragile remnant grove by the 20th century. Adopted as St Helena's official national tree in 1977, the species nearly suffered a final catastrophic blow in 1991 when an invasive sap-sucking insect called the jacaranda bug swept through the last surviving population, killing hundreds of trees before a specially imported ladybird species finally brought the infestation under control. The tree's umbrella-shaped canopy and drooping white flower clusters once sheltered a whole community of endemic invertebrates found nowhere else on the planet, many of which depended entirely on gumwood bark and foliage and now face their own extinction risk as the tree's population remains critically low. A dedicated replanting effort timed to the year 2000 established a new native forest specifically using gumwood, a deliberate symbol of the island's ongoing conservation efforts and community commitment to restoring what commercial logging had nearly erased forever. Despite those recovery efforts, the species remains critically endangered, its entire global population still confined to a single, small island in the middle of the South Atlantic Ocean. Karomia Gigas, first documented growing in a coastal forest in Kenya in 1977, this towering tree, sometimes reaching 80 feet with branches that only begin 35 to 40 feet above the ground, was cut down for timber shortly after its discovery, and the species was feared extinct for well over a decade afterward. A second population turned up unexpectedly in Tanzania in 1993, only to seemingly vanish again until a proper rediscovery in the Litipo Forest Reserve years later finally confirmed the species was still clinging to survival. Today, fewer than 25 individual trees are known to exist anywhere in the wild, split across just 2 isolated forest sites in southeastern Tanzania, making Karomia Gigas one of the rarest tree species documented anywhere on the African continent. The tree proved so obscure that it has no common name in English, Swahili, or any local language spoken near the forests where it grows, a rare case of a species remaining essentially nameless outside strict scientific literature. In 2021, researchers at a botanical garden in the United States successfully coaxed a young greenhouse-grown Karomia Gigas into producing its first documented flower, an unusual purple and white bloom that had never been formally described by science before that moment. The Chisos Oak, first described by botanists in the 1930s, growing in the rugged mountains of Big Bend National Park in Texas, Quercus tardifolia was believed to have gone fully extinct in 2011 when the last known individual could no longer be located anywhere in its narrow native range. In May 2022, a coalition of researchers from more than 10 different institutions launched a systematic search of the Chisos Mountains, spreading out across the terrain in a pattern one team member compared directly to searching for a missing person. And on the third day of searching, they found a single living tree, standing roughly 30 feet tall. That surviving specimen is in genuinely dire condition, its trunk scarred by past wildfire and infected with a serious fungal disease, leaving researchers uncertain whether a single future drought or fire season could finish what decades of decline had already nearly accomplished. Because no other living Quercus tardifolia has been located since, conservationists now consider the species functionally extinct even in success, since one lone ailing tree cannot naturally reproduce or maintain any genetic diversity on its own. Botanists are now racing to collect viable acorns and cutting material from that single surviving tree, hoping to establish a backup population in cultivation before wildfire or disease ends the species' last confirmed foothold in the wild for good. The Loneliest Plant, discovered in 1895, growing in the Ngoye forest of South Africa, Encephalartos woodi was found as a single clump of stems, and despite extensive searching across the surrounding forest in the decades since, not one additional wild specimen of the species has ever been located anywhere on Earth. Every individual plant of this species alive today in botanical gardens and private collections worldwide is a direct clone, propagated from cuttings taken from that one original clump, meaning the entire global population shares identical genetics down to the last living leaf. That uniformity carries a permanent biological limitation, since this cycad requires a separate male and female plant to reproduce, and because the original specimen turned out to be exclusively male and no female counterpart has ever been found, the species remains completely unable to reproduce naturally anywhere in the world. Botanists have occasionally attempted cross-pollination experiments using closely related cycad species in hopes of eventually producing something resembling true Encephalartos woody offspring, though none of those efforts have yet solved the fundamental problem of a species missing exactly half the genetic equation it needs to survive on its own. Conservationists continue searching remote, undisturbed patches of South African forest on the slim chance that a wild female specimen might still be growing somewhere, undiscovered, waiting to finally end more than a century of complete reproductive isolation. Until that day arrives, if it ever does, every Encephalartos woody on Earth remains part of a single genetic lineage, a species technically still alive, yet fundamentally unable to reproduce the way nearly every other plant on the planet does. The Sicilian Zelkova, hidden away in a single steep ravine on the Italian island of Sicily, Zelkova sicula remained completely unknown to science until its formal discovery in 1991, making it one of the most recently documented tree species found anywhere in Europe. Fewer than 200 individual trees exist across the species' entire known range. Confined to just two small, isolated valleys, a population so restricted that a single severe wildfire or extended drought could realistically threaten the majority of all Zelkova sicula alive on the planet at once. Genetic studies later revealed the species as a rare surviving relict, a living remnant of a much older group of trees related to elms that once grew widely across a warmer, wetter European climate millions of years before the Mediterranean region took its current, drier form. Adding to the conservation challenge, the species readily hybridizes with a more common related Zelkova planted nearby, meaning uncontrolled cross-pollination could gradually dilute what remains of pure Zelkova sicula genetics even within its own last remaining strongholds. Italian conservation authorities have since fenced off the core population and begun a careful seed banking and propagation program, working to secure the future of a tree species that spent millions of years surviving in complete obscurity before finally being noticed at all. Botanists studying the species now consider it a genuine living link to a lost European landscape, offering a rare, direct window into how much of the continent's forest composition has shifted since the climate began drying out millions of years ago.